Hello everybody, this is David again with another Verilog video using the Basys3 again. Here's the Basys3. In the last video we created a 1 Hz generator and blinked an LED, and I said you could use that 1 Hz signal to make a clock. Well, you know, of course you can. So in this video that's exactly what I'm going to do. I'm going to create a binary clock. I could use the LEDs on the Basys3 for the hours and minutes and a second blinker, but instead I'm going to set it up on a breadboard and output from the PMODs. These are called PMODs, and they're basically like GPIO for your FPGA. So I'm going to create the clock, hook up the wires from here to the LEDs on the breadboard with some resistors, of course. And I'm also going to use some buttons on here. I'm going to use the center button as a reset. The left button will increment the hours and the right button will increment the minutes. Without further ado, let's get into the coding. Alright, here I am in Vivado Design Suite by Xilinx. This is where we'll create our Verilog files and where we will program the board. I created a new project. Here's the name, binary clock for video. I set the board to the Basys3 during the project start, and it's an RTL project. The first thing we need to do is add some sources. So add or create design sources. You can't see this window, but you go in and select add or create design sources, and then we're going to need the 1 Hz generator, so we'll do that first. You know, when I get done creating all these files, you'll see all the names over here underneath design sources. Right now it's adding the source file. The other window that comes up, I just click OK and yes. It's where you can set up your inputs and outputs and their bit widths, but I just do it in the file. Okay, now we have the 1 Hz generator that I created in the last video. And what I'm going to do is just go to that file and grab the code and bring it in instead of retyping it up. Okay, so I've copied it and pasted it into the design. Here it is, the 1 Hz generator. And now for this clock, I'm going to go ahead and add some other design sources. I'll go through this and then I'll show you the files when I'm done. Okay, so I've created all the files. Now besides the 1 Hz generator, we need a button to bouncers. We're going to need 3 of them. We'll just make one file and instantiate 3 of them in the top module. And we also need some counters with some outputs for the LEDs. So the 1 Hz generator will tick the seconds, that will tick the minutes, and the minutes will tick the hours. And we'll code all those here right now. First, let's select the button to bouncer when it opens up over here. So for this we need the 100 megahertz clock. We need another input I'll call button in, and we need an output called button out. Okay, we need 3 temporary registers, so we'll go temp 1, temp 2, and temp 3. Now we'll create the logic, always at pause edge, clock 100 megahertz. We will set temp 1 will become the button in, temp 2 will become temp 1, temp 3 will become temp 2. And then down here we'll just assign button out equal to the temp3 register. This is a very simple way to do a button debouncer. I've seen some pretty more intricate and more involved designs, but this is a simple one that works pretty well. Okay, next we will go to the seconds counter. Alright, this is going to take an input of 1 hertz, which can't start it with a 1, so we'll call clock 1 hertz. This is from 1 hertz generator. And that's pretty much it. We need to output an increment minutes signal to 2 minutes. Okay. Now we need to create a register that can hold up to 60 seconds. 2 to the 6th is 64, so that's what we need. We need 6 bits for the counter. We'll just call it, we'll keep it short, sec counter. And we will initialize it to 0. You know, actually we want to have a reset for this. So we'll have another input that is a reset. And we don't need to initialize it. Yeah, well, we can. Now let's come down and create the logic. Always at, excuse me, pause edge clock underscore 1 hertz. So we also need that reset, don't we? Or we'll just do a pause edge reset. So if reset, then sec counter will reset to 0. Else, on the pause edge clock, if sec counter equals 59, which is the highest we want to count it to, then we will reset this to 0. Else sec counter equals itself plus 1. You can't just use the plus plus like you can in C or C++ for incrementing. Then the last thing we need to do is take care of the increments minutes signal. So this is the signal that's going to happen every time set counter equals 59. So, and I'll show you in a minute why we're going to do it like that. I can tell you. So increments minutes is going to go high when the set counter is 59, and then when it at the same time that set counter goes to 0, that increment signal is going to go off. So what we're going to do is in the minutes counter, we are going to have it respond to that signal coming in neg edge. So input increment minutes. This is from seconds. We're also going to use a reset. What else? Oh, we need to output the minutes itself for the LEDs. Okay. And then we're going to create that register, that 6-bit register. That's going to be the min counter. And we'll initialize it to 0. And down here in the always at neg edge inc minutes or pause edge reset. Okay, if reset, then min counter will become 0. Else, if min counter equals 59, then on the next increment minutes, then the counter will reset to 0. Else, it will increment. Alright, and then down here, we also need another output. We need increment hours. And this will go to hours. Okay, so we're going to take care of two assigned statements down here. We're going to set up increment hours the same way we did with the seconds counter. When it equals 59, it'll be 1, and the hours counter will respond to that neg edge. So at the exact same time that seconds goes to 0 and minutes goes to 0, the hour changes. We also need to assign our minutes output equal to the min counter. And that takes care of the minutes. Now we will go to hours. Okay, we're going to have an input of increment hours, and this will be from minutes. We will have a reset, and then we only need an output for the hours, 4 bits called hours. Now we'll come down here, create another register that is 4 bits, and call it hours counter. And we will initialize it to 12, because there is no 0 in a 12-hour clock. So we'll start it off at 12. Always at the neg edge of increment hours, or pos edge reset. Now if it's reset, then we want the hours counter to go back to 12. Else, if hours counter equals we have to reset it to, yeah, that'll work, 12. Then the next number, hours counter, will become 1. Else, hours counter increments. Okay, and now we will assign the output of hours equal to the hours counter. And that completes hours module. I didn't save seconds there. Let me save seconds. Okay, now we have 1, 2, 3, 4, 5. We have our 5 modules done. Last thing we need to do is create the top module, which will instantiate and include all the modules we just created. We are going to have coming into here the 100 megahertz clock, which is from the BASYS3. We are going to have a reset, which is button C of, I'll just call it button C BASYS3. We're going to have an input of increment hours. Yeah, we can name it that, which is going to be button L on the BASYS3, an input called increment mins. We will make that button R on the BASYS3. And I'm just going to change this so it just doesn't have the same name as what was in our actual module. Okay, now for our outputs, we're going to need one called, we'll call it blink. This will be the seconds blinker. Another output, that is the 4 bits of hours, and output of 6 bits, that is the minutes. I think that's all we need. Alright, now I'll just start instantiating all of the modules that we created. Start with the module name and then give it a name. I'll call it Uno. And now we know that we're going to have an input clock 100 megahertz in there. And just double check, go here. So our input is called that, and our output is called that, which is clock underscore 1 hertz. And so this is going to tie in from the top module, but this other one is not. There is nothing we have to put here. So we are going to create some wires, and we'll start with that one. And we'll go wire underscore 1 hertz. We'll just start with that one. We are gonna need some more wires, but as we instantiate. Okay, now we'll go to the next one, button debouncer. And since we have a button C, a button L, and a button R, I'll call it BL, just to go from left to right. And that also has, what do we have for inputs and outputs here? Clock 100 megahertz, button in and button out. So clock 100 megahertz, BTN in, and BTN out. Alright, that's going to be this same clock here. So plug that in there. And now we're going to copy and paste 2 more of these because we have 3 buttons and we need to come back and change. This one will be instance button C and this one will be button R. Okay, so now the button in for this case is called Inc Hours right here. This one is going to be reset, and this one is going to be Increments. Now, these buttons are going to be inputted to the module. They're going to go through the button debouncer, and so we need some wires coming out. So we have BL out, BC out, and BR out. Alright, that takes care of the button debouncers. Now, seconds. We're going to need some more wires here, so we'll call it sec. And then what do we have? We have the 1 hertz, the reset, the increment minutes. So, is that what it's called? No. It's called clock underscore 1 hertz. What was it called? Increment minutes. Oh, and also the reset. So let me put that here for the input. Here you go. So the wire 1 hertz is what's going to feed into that. So it's going to come from the 1 hertz generator and go into and tick the seconds. The reset's going to be the same. Actually, no, it's not. It's going to be the button C out. So it's debounced. Okay, now increment minutes, we're going to need a wire for that. Wire underscore inc underscore min. Okay, and now we'll do the minutes. Call it min. What do we have for inputs and outputs here? Increment minutes, reset, increment hours, and minutes are outputs. So we've got increment minutes is the input. We have reset, and we have increment hours as an output, and actually minutes as the output there. So let me just double check that. Yep. So our minutes in here is what's going to tie into here. So we can go ahead and put that there. The wire increment minutes that comes from the seconds is what's going to attach here. Our button C out. We'll go for the reset, and we need another wire for that one. So we'll do wire inc hour. So that one, this wire will come out of the minutes and it will go into hours. Alright, let's look at our hours module. We have inc hours, reset, and hours out. So we have inc hours, reset, and hours. This hours is going to tie into the outside of the module, so out of the outer shell. This BC out for the reset goes here, and wire increment hour is what is going to tick the hours here. So 1, 2, 3, 4, 5. So now if we look at our module hierarchy over here, you could see that our one file top clock has all of these modules inside of it. And now what we have left to do, we have a little bit more left to do in the top here. So we want the buttons to be able to increment the hours and minutes just like the signals do from the seconds. So we're going to AND them together. So I need to create a couple more wires. Wire BTNL and wire BTN R and are the names. And so let me think here for a second. So yeah, we're gonna have to change some names down here. So really this one's going to change and this one's going to change. So we're going to assign those wires a value. So we'll assign BTNL that gets ANDed equal to the BL out. So right, the signal that comes from the button debouncer. We're actually going to do OR. Wow, so I should change these to OR, not AND, because we want the previous counter to be able to increment the next counter, seconds incrementing minutes, minutes incrementing hours, and we also want, or we want the button to do it. So we have that button, and we also have the output from, yes, that doesn't change. This is what changes. What was in here? Increment minutes. There we go. We'll put that back in there in the seconds. Control V. And then, yes, we wanted to leave that one in there too. I took the 2 out that we don't want. So what we want to do is for the input to these guys. So the input to the minutes and the input hours are going to be here. So we're using this one to tick the minutes, and we're going to use control, whoops, I got that wrong. Control C. We want the right button to do the minutes and the left button to do the hours. I'm just getting this straight before I finish this code. Okay, because it's a lot to keep in your head, but I got it. Alright, so we're gonna increment minutes or hours on the OR of the button L out, or the signal that comes from the seconds, which is wire increment min. It comes out of seconds. It's going to get OR'd, and then that signal is what will do that. We do the same thing with the button R OR signal. It's going to be equal to BR out, or wire increment. Man, I got that backwards again. So this is actually increment min, and this one is increment hour. So we have the left button to increment the hour, and the right button to increment the minute. There, I got that sorted out. Don't forget the semicolon at the end of the statement. Okay, there's also something else I need to assign for the blink output. We're going to set that equal to just the 1 Hertz wire. The signal that comes out of the 1 Hertz generator is also going to tie into our blink, so we can have a nice blinking LED that lets us know that our clock's working. And I think that's all we need. Let me just make sure real quick. Yep, so now what we'll do is we will create, go up here to the plus, and we will go to, you can't see the window, but use add or create constraints. Click next, create the file, give it a name. I'm going to call it const underscore binary underscore clock. Name it whatever you like. Hit finish, and you'll see it show up under the constraints over here. Got the XDC file. Double click on that to bring it over to the editor. Now I'm going to go to my Basys3 master XDC file located in a folder on my computer. You should definitely, if you have a Basys3, you're going to need that. You can download it for free, I think from Xilinx. So I'm going to bring in what we're going to need for this. So I'm going to bring in the clock signal. What else do I need for this? So we can go to the top. So I need a clock signal. I need the 3 buttons, buttons C, L, and R. Let me grab those next. So I'll go down the XDC file till I find the buttons. I'm going to actually grab all of them and then just get rid of the ones I don't want in here. So there's the buttons. I don't need button U, so I can take out button U, and I don't need button D. So I'll take that button out. Save that. What else am I going to need? I'm going to be using the PMODs because I need 4 bits for the hour. I need 1 bit for the blink, 4 bits for the hours, and 6 bits for the minutes. So I need 11 of the basically the GPIO stuff. So let me look at the board here. We have JA, JB, JX, ADC, and JC. I'm going to use JB and JC because they're both on the same side of the board, the right side of the board over here. So I'll just go in and grab all of the code for JC and JB PMOD and bring it here. So there you can see, here's the codes for the PMOD headers. And so you can see it goes 0, 1, 2, 3, 4, 5, 6, 7. Okay, but the way they're numbered, I highly recommend getting the Basys3 reference manual. It has a nice picture of the PMODs and how they're numbered. Because the leftmost 4 pins, there's 2 rows. Those are voltage and ground. So, but the other 8 I can use. And you can see here from 0 to 7, there is 8. Now let's go back and start changing the values here. This clock, 100 megahertz, is the same name. That's why I name it such. And let's look at the buttons. We know button C is reset. So we can do a column select here, highlight these 2, and call that reset. And we have ink hours and ink minutes. So our ink hours was the left button. Ink underscore hours. And this one will be ink. Why does it keep doing that? There. inc_mins. I'll take it off of that. That thing's dangerous. Okay, Increments. Alright, so now we need hours and minutes. So it doesn't really matter which one you use. I'm going to go ahead and use JB for the hours and the blank. So you have to make sure you get the numbers right. So we have 4 bits of hours, you know, for when you're connecting up the LEDs. So, man, I don't like that being there. It's going to end up with a, that's fine. Let me column select this, come down here, and I have 3 bits of hours. There we go. And now I'm going to, so that'll be these 4 here. So I just need 1 for the blank. I can go down to number 4 and plug in for the blank, which means I don't need these. So I'll go ahead and take those out and change this whole name here to blank. Okay, now we need 6 bits for the minutes, so I'm not going to use this last one here or this one. We only need 6, and those are called minutes. Minutes. There we go. Oh, see how I can jack you up? Control Z. There we go. Now we're all set. Now we just gotta make sure we connect the correct wires from the PMODs to the board. I'll go ahead and get that set up and make the connections and restart the video. So actually, before I show you the setup, we're gonna go ahead and generate the bit stream for this, make sure it works. So I'll click on that, and I'll see you in a minute when it's done writing the bit stream. Alright, the bit stream has been completed. So the next thing we're going to do is open up Hardware Manager. And at this time we need to plug in our Basys3 board to the computer using the USB cable and switch it on. And then hit the open target, auto connect. A little window pops up saying connecting to the server. So just give it a minute, you'll start seeing some stuff populating in this window over here. There we go, the target is open. And give it one more sec, there it goes. Now we are connected to the board. We're going to connect or click on Program Device. Another window pops up saying Program, but we're not going to do that just yet. I'm going to switch the camera and show you the board, the setup. Okay, here's the setup. I got the Basys3 plugged in, got it turned on. I haven't programmed it yet. I will here in a second. Just wanted to show you the setup. I'm using a PMOD connector called the TPH2. You just connect it into the end and then into the PMOD, and then you can use these wires, female to male connectors, to plug into the board, which I did here. So I have the PMODs driving. I have 4 LEDs here for the hour, 1 here in the middle for the blink, and these 6 for the minutes. I like doing it like this. You could do it on the Basys3 board. You could use like these 4 LEDs here for the hour, these 6 down here for the minute, and then 1 somewhere in the middle for the LED blink. But doing it this way, you get to choose your own colors. I've done green and yellow. I've done red and blue. This time I'm going to do pink and purple with a white blink in the middle. Nice colors there, huh? Alright, so this time I'm going to program the board and we'll see this clock in action. Alright, so here we are with the clock running. I did have some 220 ohm resistors here, but the LEDs were just too light or too bright. I turned off all the lights and went to 2.2K, so you can see it just switched to 8 o'clock. So here's the 4 LEDs for the hour. Only this one's lit, so this is 8. Of course, that's the seconds blinker in the middle. And then these 6 over here are the minutes. So I'm going to hit the button, the reset button, to make sure that it works. And it does. It goes back to 12 o'clock. I'm going to increment the hours. It kind of skips over it sometimes. There's 9, 10. It skipped over 11. So now I'm going to increment the minutes. 3, 4, 5, 6, 7, 8, 9. Well, it skipped over 9. But the reason I think is the bouncer isn't so solid, and also if you'll remember to increment the minutes or the hours, it's on the neg edge. So whenever you press and then release the button, you're providing that neg edge input to increment them. So let me see if I can set the time here. The time I got right now is 2:50. So that'd be on these, on the minutes, it's 31, 32. I need that 16 to be lit up for 44. There's 40 or 48, excuse me, 49, 50. And I'll set the hours. There it is. It's 2:50. And just to make sure that it increments the hours from the minutes, that'll be 51, 52, 53, 54, 55, 56, 57, 58, 59. So now we'll wait for the minutes to increment and watch as the hours increments. 2, 3. As soon as the seconds counter, there it goes. So now we're at 3 o'clock. So there you go. There's a binary clock using the Basys 3 and Verilog. Thanks for watching.